Yeah, in this class, I will talk about how do you detect faults in IC engines. As you will see, or as you all know, IC engines are very important prime movers driving the motor cars, motor vehicles. Of course, today people are talking about electric vehicles. We will talk about electric motors maybe next week, how you find faults with electric motors. But IC engines per se, very easily there are certain techniques which by vibration monitoring we can measure. And if you think of an IC engine, of course, if you classify IC engines, there are two broad classification: the SI engine, the petrol spark ignition engine, and the CI engine or the diesel engine, the compression ignition engines. Okay. So, if you look at the PV diagram of an IC engine, any engine for that matter, okay. This, of course, the work done from this engine is the area enclosed by this curve, but as you all know, in any of this engine, of course, this for a petrol engine, because of combustion of the fuel, we get an pressure, which we call as the gas pressure, and this is the prime mover. This combustion of the fuel is responsible for giving rise to a pressure. Okay. And it is this pressure which is responsible for the power and so on. And then of course, in a 4-stroke engine, we have for every 2 revolutions 1 power stroke, and for a 2-stroke engine we have for every revolution 1 power stroke. So, because of this combustion, it is a force, gas force, which is coming onto the piston. If I have a cylinder, okay. Okay. This gas force, because of the pressure, is coming up, and of course, this will lead to the and so on. Okay. I will not, of course, there will be a web and so on. Anyway, but it is what happens, this gas force, and of course, because of the slenderness ratio, I will also have the inertia force in the system. So, this force as a function of time is dependent on the every revolution I will have per cylinder this. So, the frequency of this gas force is what is known as the engine firing frequency. which is nothing but where n is rotational speed in RPM. RPM is revolutions per minute, and small n is number of cylinders in the engine, and of course, k is equal to 1 for it is 2-stroke engine, is equal to 2 for a 4-stroke engine, and this engine firing frequency will then given in hertz. So, for every engine you can find out this. Now, this essentially means that all the cylinders in the engine are firing. So, if you how do you monitor the health of an engine? I could monitor the cylinder combustion pressure. But as you know, the cylinder combustion takes place inside the cylinder, and the cylinders are held in the engine block, and there are high forces. And so, from the to measure the cylinder pressure, we actually have to put a pressure sensors, which has to be put inside the cylinder, which can withstand the high pressures and high temperatures which occur inside the combustion chamber. Or alternately, we can measure the engine vibration. Okay. So, if you monitor the engine vibrations, obviously at more speed spin, more rate of combustion and more pressure in a given time. So, the vibrations level will increase. But then if you do the frequency domain analysis of the vibration signal, you can also detect the engine firing frequencies. Okay. So, this could be detected, but before I get into how to detect it, what are the possible faults which can occur in an somehow this picture has not come here. Yeah, anyway, I will show you an engine here. Okay. Let me go back to, yeah, it has come now. So, this is a typical engine where you will see in our laboratory, this is a 4-cylinder engine, which is coupled to a dynamometer, and there are 4 cylinders. There are 4 switches here, which can switch off the electrical supply to the spark plug of this engine. So, that I can create a fault by what is known as engine misfiring. Okay. And of course, you will see this is a water cooled engine. So, there are the coolant pipes, the exhaust pipe and so on. So, one of these case studies you will see here is an accelerometer to measure the engine vibrations. Of course, this cylinder has a lot of instrumentations, this engine has a lot of instrumentations as well, and there is a pressure sensors mounted inside the cylinder to measure the engine pressure. So, this is the specification of this engine. The total cubic capacity is about 1200 cc's. It is a petrol multi-point injection water cooled engine. Number of cylinders is 4 with 4 valves per cylinder, and compression ratio is 9.9. It is a 32 ECU is there. Rated horsepower is about 73 bhp at 6000 rpm and 101 Newton meter at 3000 rpm. So, what are the typical faults which can occur in an IC engine? Of course, one is loss of power. Loss of power could be because of many reasons. Weak compression, weak compression occurs because there will be a lot of blow by and the cylinder rings have worn out so much that there is a lot of clearances between the piston and the cylinder walls. So, loss of power could be because of this. Poor fuel quality and both the quantity as well. Engine misfiring because of an electrical problem. So, all this could happen, of course, and of course, this would lead to, if you are monitoring the engine vibration, this would lead to change in the engine firing frequencies or change in the vibrations, and of course, also what is known as the sound quality which you perceive would also change. And you would see in lot of the engine manufacturer, even new engines, they do what is known as EOL, end of the line testing, maybe on a dynamometer, to see the RPM, which is the BHP curve, whether it is producing as per the design specs. But sometimes even monitoring the vibration or the noise and looking at the characteristics, you can find out the faults in the system. In fact, I was approached by a company in South India, two-wheeler manufacturer, to develop such a system, and I had given them the idea of using sound quality. Okay. Okay, and the more details you can see in my website. Okay. So, here what we have done in this particular case in our laboratory, we have put a microphone inside an enclosure made around this engine, and this is why one of my students who has since graduated, who is operating the engine, and this is our postdoctoral fellow. We are recording all the signals coming out of this engine onto a tape recorder for subsequent analysis and find out the characteristic qualities of the signals when a defect has occurred. And we could artificially induce defects by switching on and off the engine. And at the exhaust side, we have a muffler, and then we have put a microphone here to measure the exhaust noise. And in this particular example, we did not measure the cylinder pressure, rather measured the engine vibration by a high temperature accelerometer. By the way, this accelerometer is very costly, and you can measure all the way up to 600 degrees Celsius using such an accelerometer. Okay. And you can see, because of high temperature, all these cablings are all metallic, okay, sealed in metals. So, once we have got the signal, we used for those of you who are interested, because I will get a time domain signal, be it vibration, a good engine or a bad engine. This is maybe bad or a good. Sometimes to the naked eye such signals are very difficult to distinguish. So, we can use certain signal features and we can classify the faults. Here in this example, we took the sound signals. So, by a method which is very popular nowadays, the support vector machine for fault classifications, and more details about this you can find in my website on some of the journal publications in this area applied to finding out bearing fault, gear faults, motor faults, of course, IC engine faults. Okay. And these are techniques. So, I will not go into the details of this, but all I need to say is I need to measure these signals, do certain feature extraction and use an SVM to detect a healthy engine from a non-healthy engine. Okay. The reason I am saying this is, vibration is we have to put a transducer, but imagine in a automobile okay, my engine is placed somewhere here. Imagine if I put in the hood a microphone, a very low cost microphone, and I have I am giving you this ideas, I have not patented them, but because there is nothing novel in patenting it, but somebody could implement this in an industry that we put a microphone and have the feature extracted and use an SVM fault classifier to intimate to the driver that there is an engine fault. Because this is very cost effective, because a driver sometimes if it is not he is not experienced or he or she is not experienced may not right away feel the loss in the power because of some malfunctioning in the engine, but this abnormal change in the noise characteristics is a good indicator to what kind of faults would have occurred in this engine. Of course, I am not going to the details of the engine. For example, there could be piston wear, there could be valve clearances, tappet noise. So, all these could be very easily quantified, because if the engine is covered and is nicely enclosed, the contamination from outside noise is not there, and this being airborne, a lot of the structure borne issues which are there with the traditional vibration measurements, because if I put a vibration transducer here, it is going to measure all sorts of vibrations because of the suspension, because of the engine, because of the transmission. So, this becomes a very complex signal compared to a noise signal which is just there inside this hood of the engine. Okay. So, this is an area where somebody can look into to monitor the health of this engine. So, I will give you an example in this case here. Of course, in this laboratory as a case study, we ran the engine at many different RPMs, okay. And I have just given you two representative RPMs, one being at 2100 RPM, another being at 1260 RPM. And the vibration was collected by that accelerometer or measured by that accelerometer for about 2 minutes. And I must tell you that this is a normal engine and we artificially misfired one cylinder. So, you can see right away there is a typo here. This should be a sound pressure here. Okay. I will go to the sound pressure here. So, you see the sound pressure here, there will be the case of misfiring at a low RPM, there is a misfiring, but the sound we are not able to detect visually in the time history. Both the amplitudes are low as compared to the sound pressure, which drastically reduces at high RPM because of misfiring, and at the end of about 30 seconds we again switched on the engine. So, once we switched on the engine, the sound shot up and then it reduces. So, when somebody is driving, it will be very difficult to distinguish between firing and misfiring, but then if you have an algorithm wherein you extract the features and do an SVM, and you can do it. And you see, this is the case of an engine vibration when we have a misfiring occurring. This is at a higher RPM and this is at a lower RPM. So, if somebody mapping of engine condition to the noise and vibration signals, you can find out the engine conditions. And I must give an example. Today, people are looking to sound quality. So, sound quality is nothing but an objective matrix for subjectively evaluating a sound. Now, when I say something is good, something is bad, somebody may say it is noisy, somebody else may say it is not noisy. So, this becomes very subjective. Okay, somebody may like a sound, somebody may not like a sound, but there is a scientific method by which the sound which you hear from any machine, be it an engine, be it an appliance, it can be quantified by few objectives like the loudness, like the roughness, like the speech interference, articulation index, etc. Of course, we all know the sound pressure level. So far, we have talked about only sound pressure level. So, there are sound quality matrix which can be measured from the time domain signal, and you can have a set of matrix which will quantify the engine condition. Okay. This is possible, and this is there in for many machines, and an operator or a manufacturer can design systems wherein such set of matrix can be done. And we have also at IIT Kharagpur used a software called TechMuff to design silencers for engines, and used sound quality to decide the most critical dimension of the silencer. So, which will tell us which is the best parameter the designer should play around with the silencer design, so that they sound the best. So, such research areas are being pursued by people throughout the world and in the industry to use sound quality as a means to find out. I just give an example in this class on how sound quality can be used to detect engine misfiring, and earlier I had told you how a rotary optical encoder could be used to measure the change in the rotational speed because of the misfiring and detect the engine misfiring frequencies. You can use a lot of signal processing algorithms like the empirical mode decomposition to find out features from signals which are highly non-stationary and where you do not require really long time length of data, which is sometimes required when you are analyzing stationary signals. So, a lot of algorithms are coming up in the world of machinery condition monitoring, empirical mode decomposition being one. At the same time, a lot of miniaturization in instrumentation, embedded systems, embedded sensors are coming up, which can help us diagnose faults in mechanical systems. Okay. So, some of those examples you will find in my book as well. Thank you.